Welcome to Module 4, Solution Architect Series, Explore Power Automate Architecture. This module is part of the Solution Architect Design Microsoft Power Platform Solutions Learning Path. Let's get started. Explore Power Automate Architecture. Introduction. Solution architects are responsible for a solution's overall design. Understanding the capabilities of Microsoft Power Automate is imperative when designing the automation for the solution. This module focuses on Power Automate and its capabilities. Options for automation and custom logic. Microsoft Dataverse provides many options for automation and custom logic. Business rules, Dataverse classic workflows, Dataverse plugins, Power Automate cloud flows, Power Automate desktop flows. This module discusses how the solution architect can decide on when they should use each of these options. Business rules. Business rules have two purposes. First, within model-driven app forms to change how columns are displayed, and second, at the data layer to validate data and calculate values. Characteristics of business rules are that they are useful for simple validation or setting of values, are optimized to run as part of the transaction for modifications that occur on the rows, can be configured to run in model-driven apps for basic UX operations such as hiding, showing columns, can't access related records, can't use connectors. Business rules can be configured to run on different scopes, single form, all forms, or on table create and update operations. Classic workflows. You can use classic workflows to remove the need for users to manually perform complex tasks in sequence and to control the activities that are required to deliver business processes consistently and repetitively. The primary scenario for classic workflows is when real-time processing is required. Characteristics of classic workflows are that they can only access related records in many-to-one relationships, are limited to operations on Dataverse data. Important. Power Automate should be the first choice for background operations. See Classic Dataverse Workflows for more information. Plugins. A plugin is a .NET assembly that you can upload to Microsoft Dataverse. Classes within the assembly can be registered to specific events, or steps, within the event framework. The code within the class provides a way for you to respond to the event so that you can augment or modify the default behavior of the platform. Characteristics of plugins are that they are custom logic that is an extension of Dataverse operations, have the ability to modify the request and response instantaneously, are able to handle complex logic, require developer skills, can be synchronous or asynchronous. Power Automate cloud flows. Power Automate cloud flows are workflows that automate repetitive tasks and streamline processes within and across systems. You can use Power Automate for the following tasks: optimizing personal productivity, sending notifications, handling approvals, gathering data, automating processes, integrating systems, orchestrating across systems. Power Automate cloud flows are the primary choice for non-real-time automation. Power Automate cloud flows can be triggered in near real-time, triggering by Dataverse events. Power Automate cloud flows can use over 400 connectors to other cloud services and data sources. Power Automate can connect to any cloud service that has a REST API by creating a custom connector. Power Automate for desktop. Power Automate desktop flows are for automation where no connector or API are available to use. Many legacy applications don't have a method for accessing their data or functionality except through their user interface. Power Automate for desktop flows use robotic process automation, RPA, techniques to automate user actions on these legacy applications. Power Automate for desktop flows can automate desktop and web applications. Power Automate for desktop flows can be run attended with the user manually initiating the flow, or they can be run unattended with desktop flows that are running on Microsoft Azure virtual machines. Power Automate for desktop flows are a valid way to perform integration and automation when no other alternative is available or when developing an integration would be expensive and time-consuming. Connectors for Dataverse. 3 connectors for Microsoft Dataverse are Microsoft Dynamics 365, This connector is deprecated and should not be used. Dataverse. Use this connector when you are not using solutions. It allows connections to any Dataverse environment. Dataverse current environment. Use this connector when you use solutions. This connector is the recommended choice, has more options than the other connectors, and is more flexible in the triggers that are available. Assess the costs of doing nothing. A solution architect should consider the effort that it will take to build an automation and then decide whether it is justified. This decision involves weighing business value against the cost of automating the process. Business value is the ongoing benefit that the business receives from the project. To assess whether it's worth automating the process, you need to understand the cost of not solving the problem. As a part of defining the business value that you hope to achieve from the Microsoft Power Platform solution, you should get a better understanding of what it's costing the organization to solve the problem in the current manner. In other words, measure the cost of doing nothing. If the business value that you will receive by automating the process doesn't compare favorably to the cost of doing nothing, ask yourself whether this business problem is the right one to focus on. However, if the business value that you receive by solving business problems is greater than the cost of doing nothing, plus development time and the monthly cost of software licenses, it makes sense to automate the process. Next unit, triggers. Triggers. Power Automate defines a trigger as an event that starts a cloud flow. These events can be initiated by a user, are scheduled, or are generated by a connector, including custom connectors. The triggers that are used in Power Automate are defined by connectors. Each connector has its own set of triggers. Connectors are divided into two groups. Tabular. These connectors are for data sources where the data is stored in tables. Dataverse is a tabular connector. Tabular connections will have triggers around creating, updating, and deleting of records. Function-based. These triggers are for cloud services such as X or Microsoft Outlook. The triggers are related to functions in those services. For instance, the Outlook connector has a trigger for when an email is received. Trigger types. 3 types of triggers for initiating Power Automate cloud flows are: automated, a flow that is started by a defined event in a connector, such as a record being created or a file being added to a file location. Instant, a flow that is run manually by a user, such as a button being pressed. Scheduled, a flow that is run on a recurring basis, such as 9 a.m. every workday or every hour. This section will focus on using the triggers for Dataverse. Automated flows can be triggered from data events in the platform's event framework. The Dataverse connector has a single automated trigger when a record is created, updated, or deleted. In the trigger step, you have to specify the trigger condition: added, added or deleted, added or modified or deleted, deleted, modified, modified or deleted. The Dataverse connector has a single instant trigger when a flow step is run from a business process flow. This feature allows a Power Automate cloud flow to be manually initiated by a user as a step in a business process flow. The Dataverse connector has a single instant trigger when a row is selected. This feature allows a Power Automate cloud flow to be manually initiated by a user from within a form for a row in a model-driven app. For example, a common pattern that is used with Power Automate cloud flows is to use the scheduled trigger to run features to retrieve all rows that are due for the day and then loop through and process them on a daily basis. Poll versus push triggers. Triggers represent notifications to Power Automate cloud flows that an event has occurred. Triggers are grouped into 2 types: poll and push. A polling trigger makes a call into the API at a recurring frequency to check for new messages. When new data is available, the trigger will run the flow. Examples of poll triggers include timer triggers. A push trigger responds to a push of new data from the service. When you are using triggers, indication of whether a trigger is poll or push will be invisible to you. The deprecated Dynamics 365 connector used polling triggers. The more modern Dataverse connector uses push triggers. Push triggers are more efficient and more real-time. Not every connector has a trigger. In such cases, you can use a scheduled trigger and then retrieve the data that has changed since the previous run. In other words, use a polling pattern. If you use this pattern, you need to ensure that you don't run the flow too often, and you should leave several minutes between each iteration. Use filters. Solution architects should consider minimizing the number of flows run for each cloud flow. A common mistake that many people make with Power Automate when creating and updating triggers is to retrieve the row and then have a condition that checks if the flow needs to do anything. With data-first connectors, you don't need to retrieve that row. The trigger step contains the new change data. Additionally, like other triggers, data-first connectors can have a filter applied to the trigger. A filter will prevent the flow run from being implemented, reducing unnecessary implementations of the flow. In the previous diagram, the when a row is added, modified or deleted trigger for the dataverse trigger has two filters that can be used. Column filter. If columns are specified, the flow will only run if any of the listed columns are modified. Row filter. If an OData query is specified, the filter expressions determine which rows can trigger the flow. In Dataverse, if a column is included in a trigger's output, it doesn't mean that the value of the column has changed. If you need to ensure that you only process change values, you need to use a plugin with pre- and post images. Note: instant triggers are not currently visible from apps in the flow in a solution. Next unit, Common Actions. Common actions. The actions that are used in Power Automate are defined by connectors. Each connector has its own set of actions. The following sections explain the common actions between Power Automate and Dataverse. The Dataverse connector has the following actions: create a new record, get record, list records, update a record, delete a record. The common Dataverse current environment connector has the same actions, including several more: create a new row, get a row by ID, list rows, update a row, delete a row, relate rows, unrelate rows, perform a change set request, download a file or an image, upload a file or an image, perform a bound action, perform an unbound action, predict by using AI Builder models. The Dataverse connector also allows the creation and use of child flows. Note: the Dataverse connector has many advantages over other connectors that should be your first choice with Power Automate. Retrieve data. When using the get a row by ID or list rows action to retrieve data, you should make sure that you specify only the column fields that are required for the flow. Most Dataverse triggers provide all fields, and you don't need to explicitly retrieve the record immediately after the trigger runs. However, the following exceptions apply. The when a record is selected trigger doesn't include many-to-one lookup fields, and a get a row by ID action will be required. The delete option only includes the ID of the row, but not other columns. Note: when you are referencing data that was previously retrieved in a flow, the data is not updated automatically after the original step runs. Get lists of data. The list rows action can help you filter data by using an OData query or a fetch XML query to retrieve data. When using the list rows action, you should filter the data on the list rows action, not in a later step with the data operation actions. Consider that the fetch XML query filters can do more advanced criteria, including related entities. Use the expand query filter to include related rows in the result. Use the Fetch XML Builder tool in XRM Toolbox to create your OData and Fetch XML queries. Enable pagination if you want more than one page of data. The page size is determined by the connector, and Dataverse is 1024. Pagination is enabled through the action settings. The limit is 100,000 rows. Note: the expand query filter can help reduce the complexity of your flows, reduce the number of API calls made, and speed up your flows. Update data. When using update a row action, you should include only the columns that have changed. This approach avoids triggering other automation and audit logging. Use the null expressions to clear values. Provide a GUID for the primary ID. If you are using an alternate key, which will perform an upsert operation by using the other data columns that you apply. Call custom actions. Microsoft uses the term action for several different behaviors in processes. For a type of process and for steps within processes and flows, custom actions are processes that are similar to classic workflows in their capabilities in terms of what can be performed with steps. In other words, action processes can use conditions and can create and update rows. Custom actions are reusable processes that can be initiated from code and Power Automate. Microsoft also includes several built-in actions such as set Word template, creates a Microsoft Word document from a Word template, add to queue, adds a record to a queue. Power Automate Cloud Flows can call custom actions by using the Dataverse connector. You should use perform a bound action for action processes that are associated with a table, and use perform an unbound action for action processes that are set as global. Next unit, error handling. Error handling. When a failure happens in Power Automate Cloudflow, the default behavior is to stop processing. You might want to handle errors and roll back earlier steps in case of failure. A solution architect should specify how errors are to be handled within Cloudflows. Run after. The way that errors are handled is by changing the run after setting in the steps in the flow, as shown in the following image. Parallel branches. When using the run after settings, you can have different actions for success and failure by using parallel branches. Change sets. If your flow needs to perform a series of actions on Dataverse data and you must ensure that all steps work or none of them work, then you should use a change set. If you define a change set, the operations will run in a single transaction. If any of the steps error, the change sets that were made by the prior steps will be rolled back. Note: change sets are only available with the create, update and delete actions in the Dataverse connector. API limits. The platform has API limits and service protection limits. Power Automate observes these limits. Each step in a flow consumes an API call. Limits are also applied for certain actions in Power Automate and for Power Automate. Many operations, like the apply for each loop, only work up to 100,000 iterations. You might be required to partition work when working with large sets of items. The do until loop has a default of 60 loops or 1 hour of runtime. If it exceeds these limits, it exits the loop without error. You can increase the number of loops and time in the settings for the action. Flows can run for a maximum of 30 days. You should not use long-running flows. Use scheduled flows that check if the row needs to be processed instead. Connectors have throttling limits. For instance, the Dataverse connector permits only 6,000 API calls for each connection every 300 seconds. Next unit, best practice. Best practice. Several options are available for your team to make the flows that they build more maintainable. Use meaningful naming conventions and make sure that you consider admins and users. Rename each action, such as renaming the list rows action to list account contacts instead. Use comments on actions to document purpose. Use child flows to prevent overly complex flows or repeated logic. Parent and child flows. Using child flows allows you to separate parts of a flow into reusable child flows. To create a child flow, you must create the flow in a solution and then use the Dataverse trigger. The child flow can use the following triggers: manually trigger button, Power Apps, HTTP request. The parent flow must also be in a solution, and then it can use the run a child flow action. The child flow can pass data back to the parent flow with the Power Apps or HTTP response, as shown in the following image. Use service principle. When running flows, you need to understand the user context that the flow runs in. For an automated or scheduled flow, the flow will run as the owner of the flow, and the existing connectors in the flow are used. An owner can edit and change the connections that are used. For instant flows, the owner can define that the flows run as the owner or will run as the user and require the user to create connections by using their own credentials. By default, when you add an action and sign it to a connector, it uses the current interactive user's credentials and will therefore run in that user's context. Alternatively, you can sign in with a service principal by using an app user that was created in Azure AD. This approach allows actions to be implemented by using a Dataverse app user context. Next unit, business process flows. Business process flows. Business process flows, or BPFs, are a capability of Microsoft Power Platform that helps users observe a defined business process, find out where they are in the process, and know what data is required to complete the next stage. Business process flows are used within model-driven apps to help guide the users through multiple steps and stages. A business process flow consists of stages and steps. A stage is linked to a Dataverse table, and steps are typically linked to columns in the table for the stage. The business process flow is shown at the top of the form in a model-driven app. Capabilities. Business process flows are interactive guides for users to get work done and to track major milestones in long-running business processes. Business process flows have several capabilities that can be used in your solution to aid business processes. Stage gating. The steps in a stage can be mandatory, preventing the user from moving to the next stage in the process until the step has been completed. Conditional branching. The business process flow stages can alter which is the next stage in the process based on entered values. Multiple tables. A business process flow can include up to 5 tables in the process. Switch. A user can switch from one business process flow to another at any time. Security. Business process flows can be linked to security, which allows different people to use different business process flows. When a business process flow is created, a table called the process table is created. This table is used to track the instances of the business process flow and their current stages. You can add this table to a model-driven app navigation, and you can create reports, charts, and dashboards to show usage of business process flows. A Microsoft Power BI template app provides visualizations for running of business process flows. Automation and developer APIs. Process management can be automated by using the API or by Power Automate to start-stop the process and advanced stages automatically. Use cases. Good candidates for using business process flows include encourage outcomes, not wizard data capture, link between the related tables, the form changes automatically from one table to another. This action hides the data model from the user. Trigger automation is based on progression between stages. Branching versus multiple processes. A decision that you might need to make with business process flows is to have one process with multiple branches or to have multiple processes. You can make the decision by answering the following questions. Do the processes need to run concurrently? Does the process need to return to the same place after the branch? How will you decide which business process flow is used for new records? Immersive business process flows. You can use business process flows as a standalone outside the context of a model-driven app by using a per-process license, which are known as immersive business process flows. You can create an immersive business process flow by selecting None for the table to associate the flow with. The created process table will then become the table where columns can be added, a form can be created, and data is stored. Next unit, check your knowledge. Answer the following questions to see what you've learned. You need to perform a calculation using related rows in one-to-many relationship. Which automation method should you use? Power Automate Cloudflow, Classic Workflow, Business Rules, Calculated column. I'm going to say Classic Workflow. Which connector should you use to run a Dataverse custom action? Dynamics 365, Dataverse, or Power Apps? I'm going to say Dataverse. You create a business process flow named BPF1 for the table named Tab1. The business process flow spans to table 2 and finishes with tab 3. Which table do you use to create a chart that shows the number of instances of BPF1 that are run by the current stage? I'm going to say tab 1. I'll change that to BPF1 actually. Okay, so first one should have been Power Automate Cloud Flow, and Dataverse and BPF1 are correct. Let's have a look at the summary. Power Automate should be your go-to tool for automation and custom logic on Microsoft Power Platform projects. Solution architects should work with their teams to ensure consistency in use and then use flow reviews to improve quality. Always strive to use solutions for your automation. Next steps. For more information, see Power Automate guidance documentation.